Hi, I'm Kogulan Ganesh from RY32. My metric number is 211363352. The subject is EMK31103 Control System Technology. And the instructor name is Dr. Muhammad Zamri and Dr. Muhammad Nazrin Shah. LAB2, Dynamic Response of Second Order System. So first of all, we got a section A, which is we need to derive this transfer function of capacitor, which is we need to calculate it. So these are the calculation. R3 is 10k, R2 is 10k, L1 is 200H, and capacitor is 10 megafarad. So these are the calculation. After we do this calculation, we get this answer, which is S over 0.1 S square plus 2S plus 50. For section A, part 2, by apply transform function in section A and using step function as input. So first of all, there's a require for two questions, which is A and B. For A, plot the response of the system by using Simulink model and verify your answer by using coding, M file and command window. By referring the answer, comment about the response obtained. So this is the example model, which is by using Simulink, which is figure 1. After that, this is the waveform, which is a step response. This is the figure 1b. For explanation, according to the graph, it is underdamped since the response oscillator until it reach the ultimate value. The system rising time is 0. The system peak time is 0.242 seconds to at 0.157 second. Settling time is amount of time 0.374, requiring for the response to be dump oscillation to attain and maintain a steady state value. So the time to come to settle this, the reaction time is 0.69 second. This is the response for final value, or steady state is 0.02. So which is it is a underdump. For section B, we have 4 questions. Consider the following second order closed loop system. So first of all, the A question is 16 over S square root plus 8S plus 16. For section B, this is the question and this is the figure model, and this is the pole 0 map, which is pole is -4 and damping is 1 and overshoot is 0 and frequency is 4. which is figure 2c. For the second question, which is 16 over s square root plus 16. So this is the question and this is the figure model, which is quite unsteady. For this thing, this is the pole 0 map. For pole 0 map, the pole is negative 0, 4, negative 0 plus 4, damping is 0 and overshoot is 100%. Frequency is 4, as much as same as this thing. For this is a figure 3c. For question 3, the question is 16 over s square root plus 5s plus 16. This is the transfer function. So this is the figure model and this is the pole 0 map, which is the pole is negative 2.5 plus 3.12j, which is imaginary part, I is, and the damping system is 0.625 and the overshoot is 8.08 for the frequency, which is 4. And for the this thing is same. This is figure 4c. This is question 4, which is 20 over s square root plus 9s plus 20, and this is the value for transfer function, and this is the figure model, and this is the pole 0 map, which is the pole is negative 4, then damping is 1, and for the overshoot is 0 and the frequency is 4, and this is figure 5c. And for justification, figure 5b depict a critical dump response of a closed loop system. This is due to the fact that two numerous real poles, which is negative 2, are placed at the same point in the real section. For 2, x-axis of the pole 0 map generated by the system depicted by the figure 2c, and the damping factor is 1 and the overshoot is 0. Figure 2b shows the significant dump response to overshoot. For the shortest time to achieve its ultimate value. For figure 3b is a closed loop system and undamped response due to its imaginary poles in the imaginary axis, which is y-axis of the pole 0 map. Generated by the system depicted in figure 3c, we can see from figure 6b that is a sinusoidal spontaneous response, which is frequency equal the position of the imaginary pole. The damping configuration is overshoot is 100%, and these are the 4b is an undamped response, and the two complex poles is negative 2.5 plus 3.12. It seems goes to the another imaginary part. In the pole 0 map generated by the system figures 7d, 7a shows the undamped response increase and decrease the oscillator and the ultimate value of damping, which is 0.625 with a overshoot which is 8.08%. For figure 5b is a overdump, and the 5c is show the real poles and the imaginary part, and it also overdump. For the discussion, the denominator in a Laplace function refers to a pole, numerator, and 0. In the S-plane, pole 0 can be identified. They are y and x axis. On an S-plane, the real part is x, x-axis and the imaginary part is y-axis. And furthermore, there's a fourth type of system response in the second order system. This lab has helped me understand the response theory and the differentiate of the four response based on their unique characteristic, which is overdump response, which is gradually increase the reference value and stop the steady state. For the zero pole, we can see the different real poles based on the overdump response. For secondly, the response in underdump, the response has the overshoot and oscillated until it reached the final value. In the pole zero map, we can see the complex poles for the function. The truth is the negative and the positive and the negative values, and the imaginary part has both positive and negative values. Aside from that, we receive an undump response. This response is easily identified because of the waveform similar to the sine wave. This response can be seen on the pole zero map, which is two imaginary poles. The imaginary poles are located in the negative and positive side respectively. Same, however, the polarity is different. For example, the +4 and -4, the imaginary S-plane. Last but not least, we receive a critical muffle response. This response is the shortest amount of the time to complete value steady state. This response can be determined by two identical multiple real poles located at the same x-axis point in the pole zero map. For the conclusion, in summary, as a state in section A and B, this laboratory experience investigate the use of Simulink and MATLAB for closed-loop system analysis. Furthermore, the output response obtained the view the input step. M-file command window has been captured by using technique that are demonstrated in section B. For tracing the role, and for the section A contain the describe how to transfer function from the electrical circuit. This process of generating the output using step input and the M file or command window is also described. As the result, all of the experience objective has been met, been successfully attained. Thank you.